Hello, everybody. Welcome back. We are starting Unit 5 today, which is very exciting. And we're starting Unit 5 with a foldable about the properties of exponents. So in your, you should have these pages in your packet. This packet is starting on page 12 for me, but it could be a different page for you. But this is what the foldable is going to look like. So it looks like there's 1, 2, 3, 4, 5 different color pages that you're going to rip out of your packet, and you're going to cut around the outside of all of these, right? So we'll cut around the outside there. Like the next page has 2 of them, and we cut around the outside, and so on and so forth. And then at the top, it says staple here, page whatever. This says page 6, right? So you're going to put these in order of the page numbers, and then you're going to staple it at the top. And so what the final product will look like is just this right here. It'll say property of exponents, and then it'll have all of these different categories. And so this is what mine looks like, right? So I've stapled it twice at the top, and then it has all of these different little tabs. So if you have not made this foldable yet, go ahead and pause the video and get it made, because what we're going to do in this video is we're going to fill out the foldable. And so you want to make sure that it's made so that you can fill it out. And then once we have the foldable filled out, we will just have some practice, and then that'll be it. So go ahead, pause the video if you have not made this, and go ahead and make it. Okay, so the first thing that we're going to do now is we're just going to go down in this foldable, and we're going to just go through and review all of the different properties of exponents. So the first page of the foldable is 0 exponents. So go ahead and go to that page. Okay, so the first thing that we're going to do is we're going to review 0 exponents. And here's the rule right here. This is like the most important little rule, okay? Any number raised to the power of 0 is just 1. Okay, the only exception to that is 0 to the 0, but I'm not going to bring that up, so I think it's okay. Anything to the 0th power is 1. So x to the 0 is 1. 5 to the 0 is 1. Here I have 8 to the 0, which is 1, times x to the 4th. So I just get x to the 4th. Okay, here I have x to the 3rd times y to the 0, and y to the 0 is 1. So I just get x to the 3rd. So a pretty simple rule, right, about our exponents, but one that is easily forgotten and often missed, okay? Anything to the 0th power is 1. The next piece of our foldable is negative exponents. So let's go ahead and fill in that. Okay, so here on the negative exponents part of our foldable, it says that negative exponents are not simplified. That is so important. You can never, ever, ever leave your answer with a negative exponent. Okay, to simplify, you just change the sign on the exponent. So if it's negative, it turns to positive, and then you use the reciprocal. So you flip the fraction. So let's look at some examples here. Here's a good example of what we mean, okay? X to the negative 2. I can't have a negative exponent. So I make this a fraction by putting it over 1. And then I flip the fraction. I take the reciprocal of the fraction, right? And then the exponent becomes positive. And that's it. So these two things are the same. So here on like 5 to the negative 3rd, we make this a fraction. I put it over 1, and I take the reciprocal, which would be 1 over 5 to the positive 3rd. And that's it. Same thing here if it's a negative. Doesn't matter. put it over 1, flip the fraction, 1 over -5 to the third. So only the exponent changes, okay? Not the actual number, not the base, just the exponent goes to positive. Now, if the exponent is already on the bottom like this, right? Then I still just take the reciprocal. So this like kind of in between step is I take the reciprocal, so it becomes x to the positive third over 1, which is just x to the third. So that's just the in between step. So if it's on the top, you move it to the bottom and it becomes positive. If it's on the bottom, you move it to the top and it becomes positive. So you're just changing the side in which the exponent is on. Then when you get something like this, right? So I have a 2. The 2 is positive. The exponent, remember the exponent on the 2 is a 1. That 1 is positive, so that's okay. And I'm going to go ahead and make my fraction. Then I have x to the -2. Can't have negative, so it has to go to the bottom. It becomes x to the positive 2. Then I have y to the third. So that can stay because 3 is positive. It doesn't need to move. Then I still have a 4 on the bottom. And then z to the -4th. I can't have a negative, so that needs to go up top. It becomes z to the positive 4. And then you can also reduce that 2 and 4, right? It becomes 1/2. So I have 1 over y to the third, z to the 4th, over 2x squared. Okay, so again, if it's on the bottom, it needs to go to the top. If it's on the top, it needs to go to the bottom. Again, another one that tends to be a little bit more on the confusing side. So if you're struggling with this or you just can't remember, just reach out and we can get help on it for sure. The next one that we're going to look at is the importance of parentheses. And you know, it's important enough that it has its own page, right? So let's look at that. Okay, so here, the importance of parentheses. Parentheses determine what the exponent applies to. So what I mean by that is 3 to the 4th is not the same as -3 to the 4th, which is not the same as -3 in parentheses to the 4th. All three of those things are completely different. Okay, so we're going to go over why and how do we know when to use which one. Okay, so in 3 to the 4th, the exponent is the 4 and the base is the 3, right? So this is saying, hey, I want you to write 3 4 times. 1, 2, 3, 4. 3 times 3 times 3 times 3 is 81. Okay? And you can do it like this way. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. If you don't believe me on how we got 81. Okay. Now, if I have a -3, but it's in the exponent, okay, this tells me the exponent is 4, right? The base is -3. The 4 is applying to the whole thing. The 4 is touching the parentheses. So this is telling me, hey, I want to write -3 4 times. Right? So I get 9, and then here I also get 9. So I get positive 81. Right? So you just have to pay attention. Is the 4 touching the parentheses? And you know where this comes up a lot, and this is just a side note, you guys do not have to write this down, but how many times have you told me, hey, I entered -3 squared into my calculator and it told me it was -9, right? And you're like, but it's not. I know it's not. That's because when you enter a negative into a calculator, you have to do it in parentheses. Right? It's -3 squared. Because here what happens if you don't use the parentheses, the exponent is a 4, right? But the 4 is only touching the 3. So the base is not -3. The base is just 3. So what it says is, hey, I want you to write 3 4 times and then have this negative come out front. And that negative is just going to stay out front until the very end. So that's why here we got -81 versus here was 81. Okay, and that's why again here, if you don't enter those parentheses into your calculator squares the 3 and then brings the negative out. And that's not what you want. Okay, sometimes it's what you want, right? But it's not most of the time when you guys are arguing with me and you're like, no, but the calculator told me that -6 squared was -36. It's because you did not put parentheses around the negative. Okay, so this is why this importance of parentheses gets its own page, because it is so important. It is frequently missed. And so you just want to make sure that what you're entering into your calculator or what you're actually calculating is what you intended to actually calculate. Okay, the next piece of our foldable is adding and subtracting exponents. So let's go to that page. Okay, so here we are adding, subtracting. So when you're adding or subtracting expressions with exponents, all you have to do is just combine like terms. This is super, super important. There's no exponents change. You're not, oh, I did not mean to cross that off. Jeez. Exponents are not changing when you add or subtract. You're just combining like terms. So important, okay? So like here, we have 3 examples. I'm just combining like terms. So here I have an x cubed, an x cubed, an x cubed. So that tells me that I'm going to have x cubed, right? And then I just add 9 plus 3 plus 2. So 9 plus 3 is 12 plus 2 is 14. So I just get 14x cubed. I'm just adding, or I'm just combining my like terms. Okay, again here I have x to the 5th and x to the 5th. So they are like terms. 4 minus 2 is 2. So I get 2x to the 5th. Okay, here I'm going to combine my like terms. I have x squared and x squared. Okay, so that tells me it's 5 minus 3, which is 2. So 2x squared. Then I have an x term. None of my other terms have just a 1x, so it'll be plus 4x. It doesn't change. And then I have positive 3 plus 5, which is 8. So I'm literally just combining my like terms. If it helps you, there's other ways that we can think about it, right? We can say, okay, I have 5x squared minus 3x squared. That's one like term, right? Plus my 4x plus my 3 plus 5. And so that's just kind of grouping things by their like terms. So if that's a way that you like to think about it, or if that helps you, then you're more than welcome to do it that way. But when adding or subtracting, right, the exponent does not change. We are just combining like terms. Okay, next one is multiplying and, just multiplying. So let's go to that page. All right, so it says to multiply, terms must have the same base. If I'm multiplying an x by a y, okay, I'm not going to be able to combine those two together. Okay, so the base stays the same and you add the exponents. It is so common because people think, oh, because I'm multiplying these together that I multiply the exponents. And we don't, okay? So if I have this, here's a good example. X to the 5th times x to the 7th. The bases are the same, right? They're both x. And so then I just add my exponents together and I get x to the 12th. Okay, so let's look at some of these. Here's another really good example. 4x cubed y squared times 2x squared y to the 4th. So I multiply my numbers together, so 4 times 2. I multiply my two x's together, so x to the third and x squared, so I add those exponents. And then I multiply my two y's together, which is y squared, y to the fourth, so I add those exponents. So that's how I get 8x to the fifth, y to the sixth. Okay, so let's look at my examples. I'm going to scroll down. Oh, I can fit them all. That's good. Okay, so the first one, right, this is 4 times 3 times x to the fourth. So if it helps you to group it by variable, you're more than welcome to do that, okay? So 4 times 3 is 12, and then x times x to the fourth, right, that's x to the 1 plus 4. Remember, if there's no exponent, it's a 1. So that's going to get me 12x to the fifth. Right there. Let's look at the second one. I can do the same thing. I have 3 times, the number here is 1. I don't really need it, but if it helps you, we can do it. 3 times 1 times 2. Then I'm going to multiply my x's, x to the seventh times x squared times x to the third. And then I have y to the fifth times y to the 1. Again, if there's no exponent, it's a 1, right? Okay, so 3 times 1 times 2 is 6. Then I have x to the 7 plus 2 plus 3. And then y to the 5 plus 1. Which gets me 6. X, 7 plus 2 is 9, plus 3 is 12, so x to the 12th, y to the 6th. Now I am writing out every single step. You're more than welcome. You can just skip ahead, right? You can go from here to here or whatever works for you, okay? So I'm just saying you don't have to write out every single one of these steps, but for the sake of notes, I think it's helpful. Okay, for my third one, I have x to the third times, x to the negative fifth, and then y squared times y to the third. So this is x to the negative 2, and then y to the fifth. So hopefully that makes sense. However, I cannot have negative exponent. So I need to put this over 1, and then this x needs to come down. So my y squared is, or y to the fifth, excuse me, is going to stay on top, and then x squared goes to the bottom, and the 2 becomes positive. So again, you cannot leave your answer with a negative exponent. All right, last one here. I have negative 2 times 3. I have x to the 3. I'm just going to go ahead and start adding it, plus negative 4. And then I have y to the negative 2 plus 5. And then z to the negative 2. Okay, so this gets me negative 6, x to the negative 1, y to the third, and z to the negative 2. So since I have negative exponents, I need to make this a fraction, put it over 1, and these negative exponents need to come down. Now, this 6 is negative, but the exponent on the 6 is a 1. The exponent is not negative. So just keep that in mind. The exponent can't be negative. The number is fine to be negative. It's just the exponent that can't. So the negative 6 is going to stay on top, and the y to the third is going to stay on top because those were both positive exponents. And then on the bottom, I'm going to have an x to the 1 and I'm going to have z squared. And you can write the 1 on the x if it helps you. Okay, and that's it. Right? Well, that's it, right? It makes it sound easy. You're just adding the exponents, okay? So when you are multiplying your bases together, you are adding the exponents. Any of this at any point is not making sense, just make sure you reach out. Okay, the next one is raising a power to a power. So we're going to go ahead and find that page. All right, so now our next slide is raising a power to a power. So this is the example here, like if I have x to the 5th to the 6th power. So when raising a power to a power, you distribute the exponent. So we multiply the exponent in. Basically, the base stays the same and you multiply the exponent. So here is where you multiply the exponents. Okay. When you multiply the bases, you add the exponents. When you raise a base to another power, you multiply the exponents. So let me show you, let me scroll down so we can see this. Okay, so our examples here, and I'm just going to show you this, x to the 5th to the 6th. What this is asking me is to write x to the 5th 6 times, which of course I'm not going to be able to fit. 5, 6, right? So that's why this is 5, 10, 15, 20, 25, 30 x's. So that's why we can just multiply it. Multiply the 5 and the 6. Okay? When you have a number, remember, what is the exponent on this number? It's a 1, right? So don't forget that, because then this 4 has to multiply to all of the exponents, even the ones that aren't written. So I get 2 to the 1 times 4, which is 4, and then x to the 3 times 4, and then y to the 2 times 4. And then I'm able to actually simplify that out. 2 to the 4th is 16, 3 times 4 is 12, and 2 times 4 is 8. So we just want to make sure that we're really careful with our numbers here. And I'm not able to fit all of these on 1, so we'll make it work. Okay, so here again, the exponent on this 3 is a 1. So I have to make sure that I'm paying attention, right? So I distribute the 5 to every single piece of this problem. So this tells me I have 3 to the 1 times 5 is 5. Times x to the 3 times 5, which is 15. Maybe for the first one, we'll actually write it out. So 1 times 5, 3 times 5, times y to the 2 times 5, times z to the 4 times 5. 3 to the 5th is 3 times 3 times 3 times 3, 5 times, right? That's 243. And then 3 times 5 is 15, so this is x to the 15. 2 times 5 is 10, so y to the 10th. And then 4 times 5 is 20, so z to the 20. And that's it. What if you're multiplying these together? It's the same thing. I still need to distribute my 4 and then also distribute my 2. Remember, what are the exponents on these guys? They're 1. Okay. So this becomes x to the 3 times 4, which is 12. Y to the 2 times 4, which is 8. And I'm multiplying that by negative 2 to the 1 times 2 is 2, so negative 2 squared. And then x to the 1 times 2, which is 2. And then y to the 3 times 2, which is 6. Okay, and now I can just figure out all this stuff. Now I'm just multiplying it, right? So now I would add the exponents. So negative 2 squared is just 4. Then I have x to the 12 plus 2 and y to the 8 plus 6. Right now I'm adding my exponents because I'm multiplying the bases together. So my final answer is going to be 4 x to the 14th, y to the 14th. So just make sure we're paying attention. When are we distributing, or when are we multiplying our exponents, and when are we adding our exponents? Okay, let's scroll down and look at our last two. Again here, exponent on my 2 is a 1, exponent on my z is a 1. And I'm going to distribute this negative 4. So this gets me 2 to the negative 4. X to the negative 2 times negative 4 is positive 8. Y to the 3 times negative 4 is negative 12. And z to the 1 times negative 4 is negative 4. So I have a lot of exponents here, right? And a lot of negative exponents. So I'm going to put this over 1, and all those negative exponents need to come down. So what's left on the top is an x to the 8th. What's left on bottom is 2 to the 4th, y to the positive 12th, z to the positive 4, right? Because once we move it down, it becomes positive. And then the last thing I can do is I know what 2 to the 4th is, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16. So 16y to the 12th, z to the 4th. So again, making sure that we're paying attention to negative exponents. Okay, last one. Notice I have something being raised to a power being raised to another power. There's two different ways that you can do this. I can multiply this 3 to the 2 and make it a 6. Or I can multiply this 2 in. So you start on the inside. Remember, this is 3 to the 1 and y to the 1. So this gets me 3 squared. X to the 2 times 2 is 4. And then y to the 1 times 2 is 2. All being raised to the third power. Then I can go ahead and do the 3. Which gets me 3 to the 2 times 3 is 6. X to the 4 times 3 is 12. Y squared to the third is y to the 6th. And then the last thing would just be to figure out what 3 to the 6th is. And you can put that in your calculator. That's not something that I expect you to know off the top of your head. But here it's 729. X to the 12th, y to the 6th. And that is my simplified answer. Okay, so again, hopefully we're feeling pretty decent here. We just have a couple more pieces of our foldable to review and we're done. The next one is all about dividing our exponents, so let's head on over to that page. All right, so dividing exponents, here we are on this page. It says to divide, the terms must have the same base. So same thing as multiplying, they have to have the same base. And when dividing, the base stays the same and you subtract the exponents. So I want to show you a little trick that I actually use in my head, and it seems to help me a lot, to show you as to why we subtract. So here if I have x to the 8th on top, that means that I have 8 x's. 4, 5, 6, 7, 8. Right? I have 8 x's on top, and I have 4 x's on bottom. And this is something that I do in my head very, very quickly, okay, right? So I say, okay, I have 8 on top, 4 on bottom. I can cancel out anything that's both on top and bottom. And how many do I have left? Well, I have 4, so I have x to the 4th. And then I say, is it on the top of the fraction or the bottom of the fraction? And I say it's on the top of the fraction, so it's really like x to the 4th over 1, which is x to the 4th. So that's why we subtract, okay? And so sometimes I like to use that just quick mental math of how many are left, where is it located? So let's look at our examples here. The numbers are just going to simplify like normal, right? So 2 over 6 simplifies to 1/3. That's no big deal, okay? Then I have 7 x's on top. 2, 4, 5, 6, 7, and 3. Oh, sorry, 5 x's on bottom. 4, 5. So this is going to be the last time I draw it out like this, right? I can cancel out 5 of them, and I have 2 left, and it's left on the top. So on the top, I have 1x squared, and on the bottom, I have a 3, and that's it. Okay, so again, it's something that I do in my head very quickly. So let's look at the second one. 12 over 3 simplifies to 4 over 1. You don't really need the 1, but it's there in case you want it. Here I have 1x on top and 5 x's on bottom. So 1 can cancel and I'm left with 4, and I'm left with 4 on the bottom. Okay, then my y's, I have 4 on top, 2 on bottom. So 2 can cancel, and I'm left with 2, and I'm left with 2 on the top. And then the last one, I have 2 z's on top, 1 z on bottom. 1 can cancel, and I'm left with 1 on the top. And there it is. Okay, so that tends to be how I do it in my head. You also can do the subtraction rule, right? Where I say, okay, I have 4, because 12 divided by 3 is 4. And then I have x to the 1 minus 5. I have y to the 4 minus 2. And I have z to the 2 minus 1. Which gets me 4x to the negative 4. Y to the 2, z to the 1. I have a negative 4. Can't have it, so I have to move it to the bottom. So on the top, I'm left with 4y squared z. And on the bottom, I'm left with x to the 4th, and now the 4 is positive. So notice you get the same answer either way. So whichever way you like is perfect by me. Okay, let's look at one more here. All right, 6 over 36. So that simplifies to 1 over 6. And then again, we have multiple ways that we can do this, but my personal preference is I always want to get rid of the negative exponents first. Okay, so I have x to the negative 5th. Well, let's say on the bottom, I already have an x to the 5th. On the top, I have x to the negative 5th, so that's going to come down and become positive. Okay, my y's, I have y to the negative 1 on top. Can't have negative, so that's going to come down and become a positive 1. And then my z's, I have 1 z on top, and then z to the negative 3 is going to come up and become positive. And now I can just simplify, right? I have 1 z to the 4th on top, right? 1 plus 3. And on the bottom, I have 6. X to the 5th times x to the 5th is x to the 10th, and then a y. So hopefully that makes sense how we got that. Yeah? And here's my hand. Boom. If there's any questions on that, make sure that you guys reach out. Let me know. And yeah, cool. Okay, and then the last one is multi-step problems. What happens when you have a bunch of these things all together at once? So let's look at that page. Okay, so this is the last page, and it just says to simplify the following expression. So we're just going to use all of these rules that we just went over, and we're going to simplify these. Okay, so here I need to start by getting rid of these outside exponents. So I'm going to distribute. It gets me x to the 9th, y to the 12th times, and then I'm going to distribute my negative 2. Remember that this is x to the 1, right? So I have x to the negative, oops, not negative 1, excuse me, x to the negative 2, y to the negative 6. Now I can simplify these by combining them. I'm multiplying them. So it becomes x to the 9 plus negative 2, y to the 12 plus negative 6. So my final answer is I get x to the 7th, y to the 6th. And since there's no negative exponents, I don't have to simplify it anymore. And that's it. Okay. Same idea here. This is 3 to the 1 and y to the 1. I'm going to distribute my 2. So I have 3 squared x to the 4th y squared. Okay, now I'm going to distribute this 2. Remember again, exponents, right? I'm going to distribute this 2. So it gets me 2 squared x squared y to the 6th. And that is still being raised to the 4th power. So now I also have to distribute the 4. So I have 3 squared x to the 4th y squared, that has not changed, times 2 to the, 2 times 4 is 8, so 2 to the 8th, x to the 8th, y to the 24th. And we just keep solving, right? 3 squared is 9 times 2 to the 8th is 256. And then I have x to the 4th plus 8 and y to the 2 plus 24. So 256 times 9 is 2,304. Then I have x to the 4 plus 8 is 12. Y to the 2 plus 24 is 26. So there I am, completely simplified. All right, 2 more. I want you guys to go ahead and pause the video and try these 2. And then when you're ready to go over them, hit play. All right, so let's look at these. There's lots of different ways that you can do this. I sometimes like to distribute the 5 first and then simplify, or sometimes I'll simplify first and then distribute. And the good news is that it doesn't matter which way, okay? So in this case, I'm going to go ahead and distribute the negative 5 first. So this gets me 2 to the negative 5, y to the negative 10, z to the 0, over 3 to the negative 5. So that negative 5 needs to go to the top and bottom. Y to the 15, z to the negative 20. Okay, so now I've gotten rid of that 5, so now I can really just start simplifying. So let's look. Z to the 0, that's just 1, so that's gone. Anything that's negative needs to go to the bottom. So I have 2 to the 5th, that's moved to the bottom. I have y to the 10th, that's moved to the bottom. Here on the bottom, 3 to the negative 5th goes up and becomes positive. y to the 15th stays on the bottom because it's already positive. And then z to the negative 20 comes up and becomes positive. Okay, so now I just simplify. 3 to the 5th is 243. Z to the 20th. It looks like 26, sorry, to the 20th. 2 to the 5th is 32. Y to the 10 plus 15 is 25. And then you always check to see if you can simplify your fraction. And in this case, 243 and 32 does not simplify. So there is my answer. And I don't like this. It doesn't really look like a 20. So let me fix that. Sorry. There's my answer. If you simplify the inside first and then distribute the -5, you'll get the exact same answer. So that's cool. And then the last one here is, you know, it's just the same idea over and over, right? I need to distribute this 2 to everything. So that gets me 4 squared, x to the 6th, y to the 8th, z to the -8th. So there's the top. Then on the bottom, I have 6 to the -3rd, x to the +12, y to the +3, z to the -3rd. So I'm going to go through and I'm going to get rid of all my negative exponents first. So 4 squared is 16, so that can stay on top. X to the 6th stays on top. Y to the 8th stays on top. And z to the 8th goes to the bottom. So I've just gone through the whole top and moved everything that I needed to. Now on the bottom, I'm going to move things around. 6 to the 3rd is 216, and that goes to the top because it's a -3. X to the 12 stays on the bottom. Y to the 3rd stays on the bottom. And z to the 3rd goes to the top. So now I'm just going to start combining like terms. 16 times 216 is 3456. Let's look at my x's. I have 6 x's on top, 12 x's on bottom, so 6 of them cancel. I'm left with 6, and I'm left with 6 on the bottom. Okay. Then my y's, I have 8 on top and 3 on bottom, so 3 cancel, which means I'm left with 5, and I'm left with 5 on the top. And then z's, I have 8 on bottom, 3 on top, so 3 cancel, and I'm left with 5 on the bottom. That's it. So really these rules, it's kind of the same rules like over and over and over again. You're just using them in different capacities. Okay guys, that's the whole foldable. You have some practice now to do. If you need help on any of this, make sure you reach out and we'll see you later.